Hello everyone, welcome to the sixth interaction session of network analysis. So in this week sir has covered various network theorems and how to apply those network theorems in solving different circuits. So most of these network theorems are used so that whatever the question is asked for a specific branch or specific element, uh, some sort of simplification can be done for the circuit so that it like we get to the solution without really going into the KVL or KCL equations of the entire circuit. So in this tutorial we'll be solving a couple of electrical circuits and we'll be using the theorems that have been taught. So the first question that we have is one circuit is given as shown here in this figure where the input voltage is given. Just hold on. Okay. So as I was saying, the input voltage of the circuit is given, but rest of the circuit parameters are not given. For example, this resistance or this capacitance, all these values are not given. In fact, it is told that across the end terminal of this circuit, A and B, which is the voltage across this terminal is represented by VAB, that voltage is given in the question. It is given this open circuit voltage between A and B is given by this function in terms of in time domain, and if the terminal A and B are shorted, then a short circuit current from A to B is flowing, which is given by this equation. So if this two terminal is shorted, then this IAB, which is flowing through the circuit, is given by what is given in question. Now this is the initial condition of the circuit. Now if the circuit is modified, that is a resistance is connected, so a resistance is now connected across this circuit, then what will be like what will be the current that will be flowing from A to B. So this is what you will have to find out. So so that time, so let's redraw the circuit. If the resistance is connected, so whatever the circuit parameters are beyond this particular point A and B, actually we do not need to really look into. We are interested only in the part where this terminal A and B is there, and then there a circuit, a resistance of 2 ohm is connected, right? So in the question it is given, using Thevenin's theorem in Laplace domain, find the values of A, B and tau, where A, B and tau represents the coefficient of the current waveform, right? Current which is given by in terms of A plus B e to the power minus t by tau, u of t. So whenever a circuit is given, and you know the terminal voltage of the circuit, in this case it is VAB, you can either use Norton's theorem or Thevenin's theorem to solve the new current that will be flowing through whenever an external resistance or whatever the circuit element be is connected at the terminal. So everyone with me on this one? Right now you have this VAB, right? And you have the current IAB. So you don't really know. In case of Thevenin's theorem, what does it state? That whatever be, if this is a linear network in which there may be other circuit elements, for example, here there is a voltage source, there is a resistance, there is a parallel like combination of and series combination of resistance and a capacitance. Whatever be it, if this is a linear network, then it can be replaced by an equivalent voltage, which is known as the Thevenin's voltage, in series with a resistance which is the Thevenin's equivalent resistance. This resistance is actually the resistance of the circuit as seen from this terminal AB, and in which the sources, for example in this case this is the voltage source, these are replaced by its internal resistance. So voltage source will be like short circuited and current source will be open circuited. Guys, please try to join in time. So yeah, so in this case when we are to apply the Thevenin's theorem, so this terminal AB, this entire circuit whatever it was shown in this picture is replaced by this V Thevenin's, which is equal to VAB in this case, which is given in the question. So we already have it. What we do not have is this R Thevenin, right? However, we have this short circuit current that would have flown if this terminal AB is short circuited. So we have this ISC. So when we have this current across this terminal and the voltage across this terminal, we can calculate this RTH. This may be RTH or ZTH if it is like a combination of like resistance, inductance and capacitance. So let's write in terms of ZTH instead of RTH. So can we calculate ZTH?
B Thevenin by ISC.
Right. So it will be VThevenin by ISC. Now solving this in time domain would require like you know non-linear equations. So what we will do is we'll convert it to S domain and then calculate. Sorry. So what we will do is ZTH will be equal to VAB, in this case it is V Thevenin in S domain by ISC in S domain. So what is so we will take the Laplace transform of what is VAB. It is 10 into 1 minus e to the power minus t by 2 into u of t divided by Laplace transform of 4 u of t, right? So if we take the Laplace transform of 10 into 1 of u of t, the first term, this u of t will go inside and it will be 10 into 1 into u of t. So it will be, what will be the Laplace transform? It is Laplace transform of u by t, right? So Laplace transform of u by t is 1 by s, right? Next, what will be Laplace transform of e to the power minus t by 2?
1 plus S by S plus 1 by 2.
So Laplace transform of e to the power minus t by 2 u of t. So u of t, we know Laplace transform is y of s, right? This is 1 by s. Now whenever a term u of t is multiplied, s goes to s plus a. What a is the term which is given here. So consider this in the form of e to the power minus at, right? So instead of 1 by s, it will be 1 by s plus a. So in this case, a is minus a is half, right? So it will be half. Do you remember the Laplace transform we did last time? So it is like this. Uh, Laplace transform of e to the power at u of t is given by 1 by s minus a. You remember this, right? I hope.
Yes,
Can
ma'am. Yes, ma'am.
yeah.
Yes, ma'am.
So it will be s 10 by s plus half, and the denominator will be 4 by 1 by s, only Laplace transform of u of t. So let us simplify this and write. So I'll just use a different color, otherwise it will get mixed up. So yeah, this will be equal to, so 10 we can take common outside, so 10, and in the denominator there is 4. So let's take 4 common. Now this becomes 1 by s plus sorry, minus 1 by s plus half, and this s goes up, right? So zth in terms of s is equal to 10s by 4. Now this inside the bracket part we will simplify, so it is 1 by s minus 1 by s plus half. So taking the LCM of the denominator, so it will be s plus half minus s. So this, now this s and this s you can cancel, so it will be 5 by 2, so only half will remain, so half of s plus half. So this is 5 by 4, 1 by s plus half. This is z of s. So now you can redraw the circuit. So you have v of s, which is given by 10 by s, 10 into 1 by s minus 1 by s plus half. This is the voltage, and zth of s, which is given by this. Now in this terminal, another resistance, in this case of 2 ohm, is now connected. So what will be this new current that will be flowing? I of s will be equal to the voltage v of s by the total resistance in the circuit. Since these two are connected in series, it will be zth plus 2, right? So v of s, like let us write in simplified terms. So v of s will be 10 into s into s plus 2, right? So this is equal to 5 into 1 by s into s plus half. So let us, since we have zth and vs, we can easily calculate I of s. So we have 5 by s into s plus half, and we have zth to be 5 by 4 into 1 by s plus half, this plus the 2 ohm resistance. So now it is just a matter of simplification. When we simplify, we will get something in terms of s. We have to take the Laplace inverse to take the current in terms of time domain, and then we can compare it with the equation that is given here and calculate a, b, and tau, right? So this is now straightforward. So can you start doing this and let me know the answer? First we'll simplify. So 5 by s into s plus half. This is 5 plus 2 into 4 into s plus half by into s plus half. So this will get cancelled. So this comes out to be 5 by s into 1 by 5 plus 8s plus 4. So this comes out to be, you have got until this. Everyone with me until this step?
Yes, ma'am. Yes, ma'am.
Okay. So now this is in terms of 1 by s plus 1 by s plus something, right? So can anyone suggest how we are going to solve this? So this is 5 into 1 by s into 1 by 8s plus 9. So can anyone suggest how we are going to proceed?
We can use partial fraction.
Yes.
We can take 8 common from each and
Yes.
8s plus 5.
Yes. So we have to free up this s term. So we will take 8 common. So it will be 5 by 8 into 1 by s into 1 by s plus 9 by 8, since we have taken 8 common. Now we will write in terms of partial fraction, in which it will be 5 by 8 something by s minus something by s plus 9 by 8, right? So if we write here 1 and 1, what will happen is, if we simplify this, what will remain? So it will be s plus 9 by 8 in the numerator minus s. So 9 by 8 will remain. So in order to balance this, because initially it was 1, we will multiply it by 8 by 9, right? Can we do that?
Yes, ma'am. Yes,
Yes,
ma'am. You
ma'am.
are correct.
Yeah. So it will be 8 by 9 into this. So it will be 5 by 9, 1 by s plus, sorry, this is minus 1 by s plus 9 by 8. So now we can take the Laplace inverse to take it to the time domain. So I of t will be Laplace inverse of whatever this equation is. So it will be 5 by 9. Laplace inverse of 1 by s is u of t. And so s plus 9 by 8. So it will be e to the power 80 times of u of t, right? What is the value of a here?
9 by 8, ma'am.
Yes.
Minus 8 by 9, ma'am.
By 8.
Minus 9 by 8, right? 1 by s plus a. Here a is equal to 9 by 8. Sorry. A equal to 9 by 8. So basically here it will be e to the power minus 80. So minus 9 by 8. Is this fine?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. So just hold on once.
Ma'am,
Yes.
8 by 9 u of t, na?
Sorry.
8 by 9 u of t. 8 by 9 missing, ma'am.
Where did I miss it?
5 by 9 into 8 by 9 u of t minus e to the power minus 9 by 8 t.
So this 8 by 9 I had taken it outside, right?
Okay, ma'am. Okay.
And I cancelled the 8 and 9 is remaining.
Okay, ma'am. Okay, ma'am. Got it.
I just let me verify once.
I just have a doubt here. Denominator 4 is there, right? 4 into s plus half. So
Okay, this is
1
5 by
4.
4, right?
Yes.
Okay, okay. So 5 by 4. So this 4 I have missed it, right?
Yes.
So this will go up. So there will be a 4 here, which I have missed in that state. So it will be 20, right? Because this 8 and 8 will get cancelled. So it will be 20 by 9. Now is this fine?
Okay.
Yeah. So we have to write in terms of a plus b e to the power minus t by tau u of t. So in the question it is given a plus b e to the power minus t by tau into u of t. So and we are asked to find a, b and tau. So we can write it in that form now. So it will be 20 by 9 minus 20 by 9 e to the power minus 9 by 8t into u of t. So the answers are just, so we have a is equal to 20 by 9. So let us just calculate 20 divided by 9. So it is 2.22. B is equal to minus of 20 by 9. So minus 2.22. What is the value of tau? Tau is equal to 8 by 9, right? Guys, please try to join in time. Okay. So we have covered the first question, in which even though we did not know the values of the different circuit parameters that are given here, only we knew the terminal voltage and the current change in the branch when a 2 ohm resistance is connected is asked. So we were able to solve using Thevenin's theorem. So these are basically the advantages of the different theorems. Everyone clear on this one? Any doubt in this question? If not, then we can move to the next question.
No, no, ma'am, no doubt.
Okay. Then let's move to the next question that we have. So in this case, first the network is given in which a voltage source is connected and a current I11 is flowing into the circuit. This is like a combination of whatever the network may be, which is given as a linear passive network, and the output terminal is short circuited and a current I12 is flowing. Now keeping rest of the circuit same, what they have done is they have connected a voltage source across terminal 2 and a 2 ohm resistance in terminal 1. Now the different voltage and the current are given, where V1 is given as 10 U of t, I11 and I2 are given. Now in the question it is asked for the same network. So this internal portion of the circuit is same for both the cases. So in that circuit, if a 2 ohm resistance is connected across the port 1 and a voltage of V2 is connected across the port 2, what is the like the current 2 1 which is given as shown here, this comes in the form of some a e to the power minus t plus b into e to the power alpha t u of t. So we have to use Teligent's theorem in order and use Laplace in Laplace domain to figure out this value of a, b and alpha, that is figure out I12. Now what does Teligent's theorem state? Like if the, as sir has taught, I guess you have seen the lectures, so if the topology of the two network are similar, then like apart from the fact that the summation of the power either delivered or absorbed is equal to 0, in which case it is VI is equal to 0. Okay, I'll write it in terms of k. VKIK is equal to 0. And also, if these two circuits have the same topology, whatever, same topology means like the way the branches are connected is same, whereas the like the circuit element in this case, for example, this and this may be different, but if they are connected in the same manner as shown here, what will happen is Like for example, the voltage across this branch, which is V2 into the current that is flowing here, which is here I2 dash. Similarly, the voltage for each branch of the circuit, like that is to say that summation of Vk I of k, this I of k dash is the corresponding current in the different circuit where the circuit parameter may be different in that particular branch. This will also be equal to 0. So in this case, if you see, like if we consider the terminal 1 1, suppose imagine if the rest of the circuit have been like this portion of the circuit, whichever is not shown, if this would have been the circuit, only this and this are changed from let's say this is network 1 and this is network 2. Only the branch V2 and V4, suppose we had changed, this would represent similar kind of circuit as shown by this network which is drawn here. So what can we do is like let's take this particular one circuit and this to be the second one with the same topology, and we can apply Telegen's theorem and calculate I11, I21, I12, and whatever this current, let's say one current I22 is flowing here. Since it is not given, I'm just assuming. Anyway, you will see later on we don't really need this current. So using Telegen's theorem, what can we write? Let's draw the network first properly. So the first network is, so in this case you see I21 and I11 are in the opposite direction. So I can just write it like this, right? This to be minus of I11 of t. I can write this so that both these directions are same. In this case also I12 and I22 are different. So let me reverse this direction and write minus I12. So that in both the cases, in both the network, the current direction is same. So that we can apply Telegen's theorem now. So for the first case, uh, if we apply summation of Vk I dash of k. So this part of the network which is not known, it is a particular constant. I hope you remember when sir has shown one of the example, like this part of the network, it will appear in both the cases and it will get cancelled using by applying KCL condition. So we are interested only in the elements that are changed, that is between 1 1 and 2 1 1 dash and 2 2 dash. So for the circuit 1, what we will have is power absorbed by this particular voltage. Now since we have changed the correct direction by writing it minus I11, the current is entering the plus side of the voltage, so it is basically absorbing power. So it will be V1 of t into minus I11 of t, and for the other branch that is across 2 2 dash, what will it be? Plus, so here the since this a current is flowing here and there is nothing connected across it, so this is basically short circuited, right? So voltage across this will be equal to 0. So it will be 0 into the current that is flowing. Sorry, this won't be I11. So let me just correct this. This will not be I11, right? In this case, I dash is I21. Everyone getting this?
Yes, ma'am.
Yeah. Into I22. So we will let's change this direction bit. So instead of writing I21 like this, what we will do is change the direction of I22. So let I21 be in this direction, let I22 be in this direction, because then we are like this positive
But
side of the,
madam, but
yes,
in sir convention, this I12 was as you are showing me, they are showing earlier.
sorry,
Uh, this I21 dash I12
yeah,
here in first circuit.
yeah.
Earlier you were showing as sir was teaching.
So
So that is
I12
the
was
status.
flowing like this, right?
I12 yes. So
Yes.
I12 minus of this direction.
So now
Okay,
what
we
I'm trying to do
continue.
is, initially, okay, I'll redraw the circuit once more and then write it. Wait, just forget this part now. So I will redraw the circuit here. So the first network. So the first network, I'm redrawing it like this. So this is the voltage. This is some unknown parameter of the circuit that we do not know, and this branch is short circuited. So right now I11 was initially flowing in this direction, right? So in the opposite direction minus I11 will flow, right? This is the voltage V1 of t.
Okay, this is okay, ma'am, and it is as per sir convention, as sir has taught us.
Yes, this is I12, right? The
Yes,
voltage
ma'am.
across here is 0. Fine.
Yes, yes, ma'am.
For the second network, so uh, so initially what I had said is, since this is a source, current I22 is supposed flowing like this, right? Now when I'm drawing the circuit, let me draw it properly, wait. So this is the unknown parameter. Now this is one voltage which is connected as V2, right? In this V2, since I wanted to keep the current direction same in circuit 1 and circuit 2, and already I22 current is flowing like this. So if I keep the current direction same, minus I22 will flow. Is it fine? Because
But sir has taken I22 inside positive polarity, madam. In
so,
the second circuit, I22 inside
yes.
positive polarity of the voltage.
So please, like, the reason behind that is, whenever there is a voltage source, if current is flowing into it, it is absorbing power. So however, in case of resistive circuit, it is dissipating this power. So the summation of those two will be same. If something is absorbing power, the net power will have a different sign than if it is, so it is absorbing and this is delivering. Now Teligman's theorem is based on the summation of these two. So this plus this should be equal to 0. So if I take I22, as you were saying, like suppose if I am taking I22 coming out of the circuit, let's say I am taking I22 like this, then this particular voltage source will be absorbing the power instead of delivering. So it will have a minus sign into V2 into I22. This will be equal, this will be additive to whatever the power that is getting dissipated here, and that will be equal to 0. So considering a current, what I am trying to say here is, like, this direction of current I am trying to keep same as this direction of current in the previous circuit. Even if I take both the current in two different direction, what I have to compensate for is, like, whether the current is coming out or coming into this V2 voltage source, because at the end of the day you have to take the sign convention correct, in which if the current is entering through the positive terminal of the voltage, it is absorbing; if it is going out, it is delivering. So when we take in the summation, you have to incorporate the negative sign in this particular uh, power equation. That is when you take I22 into V2. Now, for example, if the case is like this, and this is suppose V2, in this case, it is getting absorbed, right? If it if the case had been I22 was going out and there is a V2 here, so it is delivering power. So in this case, the power delivered will have a negative sign, I22 into V2. So either way, you see the, if you take now in place of that, if I just substitute this as minus I22, minus I22 means again the reverse direction, this is minus I22. So it is exactly same as what we had assumed earlier. So the sign convention takes into account itself depending on whether it is absorbing or delivering power. Is it making sense?
Okay, madam, continue.
Okay. So anyway, so if you want to take this in the other direction, you can take that also. Let's say you are taking I22 in this direction. So minus of I22 will be flowing in this direction. Now this resistance, this 2 ohm resistance, and the current it is flowing through it is 2 1. So this 2 ohm resistance can be substituted for a voltage source. This is using substitution theorem, in which it will be 2I21, right? Is this correct? Instead of
Yes, ma'am. Yes, ma'am.
so so we are just replacing it by 2I21, and the current that is flowing here is I of 21. Now for this two particular circuit, we'll be applying the diligence theorem. So for the first network, it will be, so it will be V1 of t into this current I2 dash, I11 dash, like in this case is I21. So it will be I21. Then the voltage across this 2 dash is equal to 0. So it will be 0 multiplied by I2 dash. In this case, I2 dash is minus of I22. This will be equal to 0. If we convert it into the Laplace in S domain, it will be V1 of S into I21 of S is equal to 0. This is the first equation. The second equation that we will have from 2. So from the second network, what we will have, now in this case, in both the cases, the power is getting absorbed. So the sign convention in both the cases will be same, because the current is entering the positive terminal of the battery, right? So it will be 2 into I22. This is the voltage, sorry, in I21. This is the voltage, right? So voltage times the current I1 dash. In this case, I1 dash is minus I11, right? So it is minus I11 plus, here the voltage is V2 on the other side, So V2 into the current that is flowing, which is I12. So I12 will be equal to 0. Now I am simply writing it in S domain. So it will be 2 I21 of S. This minus sign I am taking it out. So there will be a minus sign on the outside, into I11 of S plus V2 I12. V2 of S into I12 of S will be equal to 0. This is the second equation. So the first equation also is equal to 0. The second equation is also equal to 0. So we can equate these two equations. We can equate the right hand sides, right? So we will get minus 2 I21 I11 plus V2 of S I12 of S will be equal to V1 of S into I21 of S. Now in the question, I11 is given, V2 is given, I12 is given, V1 is given. Only unknown part is I21. So we can solve this equation for I21, right? Is it fine?
Yes, ma'am.
So
Yes, ma'am.
let's substitute the values now. So I11 is, if I take the Laplace transform, so I11 will be 5 by S plus 8, right? Since it is given 5 into e to the power minus 8t u of t. I12 is 1 by S plus 8. V2 is equal to 8 by S plus 1. So let's plug this values into this equation. So it will be minus 2 I21 of S. I11 is given by 5 by 5 plus 8. V2 is 8 by S plus 1. So it's 8 by S plus 1. I12 is 1 by S plus 8. V1 is given 10 u of t. So it is 10 by S into I of 21 of S. Now this is just one single equation and you can calculate I21. Could you please solve this and let me know if you have the answer? So it is 10 by S plus 10 by S plus 8. It is similar manner in which we solved like earlier also. So you will have to again form partial fraction and then finally take it into the time domain. So it is 5, 4, S plus 8 will get cancelled. So I21 of S is equal to 4 by 5 into S by 2S plus 8 s plus 1. We can again take 2 common, so it will be 2 by 5 into s by s plus 4 into s plus 1. So how will we solve this? We can write it in terms of partial fraction of a by b. So it will be 2 by 5 a by s plus 1 plus b by s plus 4. We can write it like this, right? Now we have to solve for a and b. So what can we write? A into s plus 4 plus b into s plus 1 is equal to s, because in the numerator it is given to be s. So this is the equation and we have to solve for a and b. So what can we do? We can put s equal to minus 4 first. Let's put, let s equal to minus 4. Then the equation becomes a into 0. So it is a into 0 plus b into minus 4 plus 1, and s is equal to minus 4. So minus 3b equal to minus 4. So b is equal to 4 by 3. Now if we put s equal to minus 1, it will become a into minus 1 plus 4 plus b into 0 will be equal to minus 1. So a will be equal to minus 1 by 3. So now we can write our I12 in terms of partial fraction. So it is 2 by 5 So it is s plus 1 and s plus 4. So a here is minus 1 by 3 and b here is 4 by 3. So now can we take, is this in the form where we can take the inverse Laplace transform? We can, right? You guys are following, right?
Yes, ma'am. Yes.
Okay. So what will be the Laplace transform of s plus 1?
It will be e to power minus 1 t
Yeah. Yeah.
ut
Yes.
plus 4 by 3 e to power minus 4 minus 4t
U of t.
ut.
So if I take it inside, it will be so for e to the power minus 4t and e to the power minus t. So let's see how the question is. It is in terms of minus t, and so the question is given in terms of e to the power minus t plus b to the power minus alpha t u of t. This is the current equation, right? So we can write it. So this will be u of t, and the coefficient of a will be minus 2 by 15, and this will be 8 by 15. So a will be equal to minus 2 by 15. 2 divided by 15, which comes out to be minus 0.133. B will be equal to 8 by 15, which is 0.533. And what will be the value of alpha? Alpha will be equal to 4. So this is the answer, A, B and alpha. So everyone followed this one?
Yes,
Yes,
ma'am.
ma'am.
Can you show the previous slide, ma'am, please?
Yeah, this one.
Yes. There is a one query I have that you have written in that here, the 10 by s plus 10 divided by s plus 8. The how that 10 came from?
Okay, this 10 in the numerator I have taken it common. This 10 and this 10 I have taken it outside.
Okay, okay, got it, ma'am.
Yeah.
Thank you.
So everything is fine then? If yes, then we can move to the next question. With respect to the current one, please remember, if the current is going out, that means this source is delivering the power, then it would have an opposite sign as compared to the power equation that is like in this case the 2 ohm resistance where it is absorbing the power. So if we had taken this I to in the reverse direction, the only change would have been, let me take the highlighted ones. So yeah, I- if this current like we had taken in the opposite direction, the sign change would have been in this particular sign, right? So in this case it would appear like it is absorbing the power instead of delivering. So the sign equation would have changed. So what like the best way would have been like to keep the both the direction of the current in both this like like the two different circuits with the same topology is to keep the either the current direction same, or like you have to take into account a negative sign while considering whether it is delivering or absorbing power, because in either of the two cases the sign will be different and their summation is equal to 0 according to Tillinghast's theorem. Please keep this in mind like while taking the current direction. Okay.
Okay, madam. Okay.
Okay, so we'll move to the next question then. uh, so the sorry So for the third question, what we have is one circuit is given where a voltage and the series resistance are connected with another branch which is in parallel with a voltage and a series resistance, which is in again parallel with a resistance R, where the current I1, I2 and I3 are flowing in the branch, where it is given the value of R is 2 ohm, I1 is 4 ampere and I2 is 9 ampere. Now in the question it is given if this particular resistance is changed from 2 ampere to 15.45 ampere and rest of the E1 and E2 values are same, what will be the new values of I1, I2 and I3? So when the value of this resistance will change, of course this current I3 will change, because of which the current distribution in branch 1 and 2 will change, and we'll have to figure out the value of this I1, I2 and I3. Now since E1 and E2 are not given, you cannot simply go about solving KCL and KVL using the new parameters. What you can however do is use the compensation theorem, in which the compensation theorem sir has taught, if you remember. So if this is a parameter Z that is connected across a circuit, in this case this entire circuit which we may not consider initially for solving I3 is this particular portion. So only the, let us consider this terminal 3 dash. So only the resistance across this terminal is changed, right? This circuit is changed from this to this, where this is equal to Z plus del Z. In this case, Z is equal to 2 and del Z is equal to, so new resistance is 15.45. So it is basically 15.45 minus 2. This is the change, right? 13.45. This is the change in resistance that is happening across ZZ dash. Now what does this compensation theorem do is, like, it substitutes the resistance in terms of voltage sources and uses superposition in order to solve it. So if you remember, the new current I3 that will now be flowing here, so I3 will be I3 plus some I3 delta I3, which is due to this change in delta Z. So the new voltage, like across this 3 dash, now the new voltage across 3 dash will be equal to I3 plus del I3 into Z plus del Z. Now if you remember, Sir had used the superposition theorem in which once it takes only the unchanged value of the resistance to calculate I3, when this I3 is calculated, it is added up, because now one source is uh, uh, like calculated at a time. So in the second case, what happens is, so let us write in terms of a, so this is written in terms of a voltage and a series resistance, because if I expand this V13, it will be I3 into Z plus, so it will be del I3 into Z plus del Z. I'm just expanding the term, okay? It will be I3 into del Z. So these are the, like when I expand this I3 plus del I3 into Z plus del Z, we can get to this term. So we are using superposition theorem once by considering the initial unchanged condition plus, so in this case, in the new circuit, del I3 current is flowing, so this will be replaced by a series resistance which is equal to Z plus del Z, and a voltage source which is given by I3 into del Z. This is using the compensation theorem, which incorporates this superposition and substitution. Why? In place of the voltage, like in place of current flowing through it and a client current flowing through the impedance, we are replacing it by a voltage which is current into the impedance, in which case this is the resistance. So for the first case, let us, so the final current I3 will be equal to whatever the I3, that let's say I3 dash, this is the I3F, let's write it I3F. So this final current will be what was initially flowing I3 plus del I3, which is because of this change in resistance. So I3 we can easily calculate. So I1 and I2 are given. So initially 4 ampere current was flowing like this and 9 ampere current was flowing like this. So applying KCL at this node A, this current will be 9 plus 4, 13 ampere. So initially I3 was 13 ampere. Then we have to figure out this del I3. So how to find this del I3? Across this 3 dash circuit. So let us draw the new circuit in which, so when we are to find del I3, what we will do is, the rest of the circuit parameters we are replacing it by their internal resistances. So this 7 ohm resistance will remain as it is. This 13 ohm resistance will remain as it is. The voltage source will be short circuited, because we are replacing in the superposition theorem, when we took one source at a time, rest of the sources are replaced by their internal resistance. So these two, like E1 and E2, we are short circuiting. Now this is del plus Z plus del Z, which is in this case given as 15.45, and only one voltage source which is equal to I3 into del Z, which is there. Now we have the value of I3. I3 initially was 13 ampere, and del Z we have calculated, del Z is equal to 13.45. So we have this voltage value 13 into 13.45, which is 174.85. Now you have this voltage, so let this be del I3. So the three currents that are now flowing will be del I2 and del I1. These are the three currents that are flowing. So once we evaluate the circuit and calculate the change in current, that is del I1, del I2 and del I3, we can use superposition principle to calculate all the currents I1, I2 and I3, right? So let's start with I3. So this now this is now just a simple circuit problem. So let's write the equation of the circuit in the next page. Take this. So I'll just redraw it. This is too small. So first we will solve for I3. So we have this, and this is 7 and 13 ohm. So 7, 13, this is 15.45. So let this be the voltage source, which is now 174.85. So this 13 ohm and 7 ohm resistance are in parallel, which is in series with this 15.45 ohm resistance. So we can write it now like this: 174.85. This is the 15.45 ohm resistance, and this is parallel combination of 13 and 7 ohm resistance, right? Which is equal to 7 into 13 by 20. Now we can easily calculate the current that is flowing. Here in this case it will be del I3, because this is the current that is flowing in this branch. So these two particular branches we had taken an equivalent resistance. So del I3 will be equal to V by R. So in this case voltage is 174.85 and resistance is 7 into 13 by 20 plus 15.45. So you can calculate this del I3, right? So what will be the value of del I3? So one thing you notice, like in this case, we have taken the direction of del I3 to be in this direction, right? But actually, because the voltage source is present here, so current will actually be in the opposite direction. So if you are to write the KCL in this loop, it will be 174.85. So we had taken initially the current direction to be this way. So it will be del I3 into 15.45 plus 7 into 13 by 20. So del I3 will actually have a negative sign, so it will be minus 174.85 by whatever this Z equivalent is, like which is 15.45 plus 7 into 13 by 20. Is it right? So the value of del I3 will have a negative sign. Is this clear?
Yes, ma'am.
So it is 91 plus
Ma'am, excuse me, ma'am.
Yes, ma'am. Yes.
But that voltage source was obtained due to substitution theorem, no, ma'am. So how can we determine that there is a source and the current is in this direction?
So initially we had assumed the current to be in this particular direction, del I3, right? So either way, like whichever direction you assume the current. So here nowhere in the like the voltage source del I3 is coming up, right? It is I3 into del Z. Is this what exactly were you asking? So this del I3 I can either take in this direction or maybe in the reverse direction. If I had taken it in the reverse direction, suppose if I had taken del I3 in this direction, then this equation here it would have a negative sign. So this would have been positive. But the direction, see in superposition theorem, suppose this is a particular branch and there is like I3 we had calculated this to be 13, then we had assumed a del I3 something which comes out to be negative x. The final summation that current that will be flowing through here I will be equal to 13 minus of x, right? So this direction is very important. Had we taken a direction in this direction of I3 would have, then the magnitude would have come to be as positive x. So now I would have been again the same thing, 13 minus x, right? Because in one case it is in this direction, the next case it is in the reverse direction. So the net magnitude of I will take into account the sign that is present. Are you getting it?
Yes, ma'am. So we are taking a delta I3s away from the source.
So delta I3 you can take like whichever direction you take, make sure when you at the end add it up, you take into account the direction and then add it up. So for now in this case we had taken the direction of del I3 to be going into the source, right?
Yes, ma'am.
So for that, like I'll just cut this part and write the equation properly. So now this is the direction. Now we are applying KCL. So KCL is we are entering through the negative side of the voltage, so it is 174.85. Then it will be, so we are moving in the reverse direction of the current that is flowing. So ideally this 15.45 resistance, since current is flowing in this direction, so right now we are assuming the voltage of this resistance to be like this, right?
Yes, ma'am. Understood.
So we are moving in KCL in this direction, so it will be plus VR, and VR is nothing but del I3 into 15.45. This again in this case, since we are assuming I3 to be in this direction, so it will be a voltage drop like this. So in KCL we are moving and entering through the negative side, so it will be del I3 into whatever this 91 by 20 will be equal to 0. So del I3 will inherently get a negative sign. So it is 174.85 by 91 by 20 plus 15.45. If you had taken the del I3 in the reverse direction, so suppose if del I3 would have been in this direction, then I'll just write for now V1, R1 and R2. So in this case, how if I had written the KCL equation, it would have been V
Yes, ma'am.
minus
Understood, ma'am.
I3. You understood it, right?
Yes,
So
yes.
then it would have achieved a positive sign, And anyway, like this direction actually is taking care of it. So up to now del I3 is fine, right? So let us just
Yeah.
calculate the value of del I3. Anyone calculated?
It's minus 8.74.
4.2575.
Okay.
Yes, ma'am. Minus 8.7425.
Minus 8.74.
7425.
7425.
7425.
Okay. So now we have delta I3. So we had taken I3 also in the same direction as delta I3, right? Initially we had assumed this. So using superposition's theorem, I3 will be equal to I3 final will be equal to I3 plus del I3. So initially we had calculated I3 to be 13 and now del I3 is minus 8.7425. So this value is 4.2575. This is the value of final I3, right? Now you also have to calculate I1 and I2. So now that you have the value of I3, you can calculate del I1 and del I2. So in this circuit, this is 7, this is 13. So whatever the voltage here is, this value is 15.45. Now this part is irrelevant. So initially we had taken del I3 to be minus 8.7425. This is the current, and this is how had we taken I1 and I2. Uh, so it was flowing into the circuit. So we had taken del I1 and del I2 like this. So what will be del I2? So KCL will be valid at this particular node. So can we? So let us just replace this. We can do both ways. First, replace the direction of current since this is coming negative, or just use this only. So when two resistance R1 and R2 are connected, and there is a current I flowing through it. Let's say in this case this is I3. So current through this is 1 and 2. So if
Ma'am,
this
is it
is,
necessary to find del I1 and I2, ma'am?
yes, because you will have to calculate I1 and I2 final. So in the question it is
Uh,
given, you'll
can't
have
we
to,
use I3 final and then determine I1 and I2 final, ma'am, based on current division rule?
yes, you can do that also. So let's check if we can directly use uh actually we are using
E1 and
no,
E2 is there, ma'am, so
no
which
no
is
no
not possible.
you cannot do that. Yeah, first of all, u1 and u2 are not, values are not given. So what we are using is actually compensation theorem. So we are calculating the del change in like current with respect to this particular voltage. So you will have to calculate del I1 and del I2. So what will be del I2 if you apply current division rule? So it will be in the reverse of their resistance ratio, right? So del I2 will be 7 by 7 plus 13 minus 8.7425. Is this correct?
Yes, ma'am.
So it will be 7 by 20 into 8.7425. So 7 into 8.7425 by 20 comes out to be minus 3.0598. Similarly, you can find del I1. So it will be 13 by 20 into minus 8.7425. So it will be minus 5.6826. So final I1, I2 and I3. So initially we had I1 to be 4 ampere. So it is 4 minus, so this is I1 plus del I1, right? So it is minus 5.6826. I2 will be, initially I2 was 9 ampere. So 9 minus 3.0598. So please calculate this, and I3 we already got. So it is 4.257. So what are the values of I1 and I2? So I1 is minus 1.68. I2 is 9 minus 3.0598. So 5.94. So these are the values of the new values of I1 and I2 and I3. Everyone got it?
Yes, ma'am.
Okay. Is there any question? If not, then we can move to the next one.
Ma'am, previous slide just for a second. Before this, okay, ma'am. Okay.
Okay. So shall we move to the next question then?
Yes, ma'am.
Okay. So in this question, a circuit with 3 different branches are given, in which the supply frequency is given to be 50 hertz, and it is said that all these phasors are represented by their RMS values. So these voltages are given in their RMS values. You'll have to calculate the RMS value of Vmn. So Vmn is actually the node voltage at point M, and you have to calculate the current IA, IB and IC. In all the RMS values you will have to calculate. So this circuit is nothing but like a circuit in which, suppose this is ZC, there is a voltage VC is given. So sorry, this is not the DC voltage, this is given in terms of a phasor. So VC is given, then there is this branch A, which is ZA, VA is given, then branch B, where impedance of ZB and a voltage of VB is connected, and this point is written to be M, this is N. Here in this case this is the neutral, because you see all these are connected to the negative side of the voltage, so this is neutral. You have to calculate Vmn. Vmn is nothing but the voltage at node M, right? So this is the circuit that is given in this way. Since it is given in the tilted version, it looks kind of different, but these two are the same. So you will have to calculate this Vm and the various currents. In this case, this is IC, IA and IB. So you have to calculate Vm and IC, IA and M. So what are you going to apply to calculate the voltage first? Vm.
Can we use a node analysis?
Yes, we are going to use nodal analysis. So before that, since this Z value is not given directly, it is given in terms of capacitance and resistance. Let us just write what are ZA, ZB and ZC so that it is simplified. So ZA is this 80 ohm resistance plus 40 microfarad capacitor. So it is 80 plus, since it is a capacitant, it is plus of minus j omega into C. Omega into C. So it is 80 minus j by omega. So what is omega? Omega is equal to 2 pi into
2 pi
f,
f.
where f is the frequency which is given as 50 hertz. So it is 2 pi into 50 or 100 pi. In this case, capacitance is given 40 microfarad. So it is 40 into 10 to the power minus 6 into 100 pi. So, so it is 80 minus j into 1 divided by 40 into 10 to the power minus 6 into 100 pi. So it is around 79.577. This is ZA. Now, what will be equal to ZB? ZB is again the same. So, oh no, ZB, the resistance is now 40 ohm and this is J by 80. Let us write in my terms of microfarad now. J omega into C. If I just write it, if I just write this, so if you consider this and this, it is just a multiplication of 2, right? So you see, if I take 2 from from this equation, if I take 2 common, so it will be 2 into 40 minus, so 2 common means I have to multiply numerator and denominator by 2, so this denominator will become 80. 80 into 10 to the power minus 6 into 100 pi. Are you getting this? So ZA is actually equal to 2 into ZB. Are you getting it? I have just taken 2 common from here, okay? So 2 common from here. So if I go to take 2 common from here, I multiply numerator and denominator by 2 and take the 2 out. So this comes out to be exactly equal to ZB. So this is 2 into this part is ZB, right? So I similarly the branch C also, which is equal to the branch IB, only the voltage is different. So ZA is equal to 2ZB is equal to 2ZC. So I don't really need to go into calculating all the branches. Maybe we'll do it later on. But right now, for writing the KCL equation, we need only this much.
Ma'am, ZA equals ZC, no, ma'am.
Just hold on. So A branch is this middle branch where the resistance is 80 ohm, whereas in case of B, this resistance is 40 ohm, and in case of C also this resistance is 40 ohm. So ZB will be equal to ZC, right? Because a 40 ohm resistance is connected with a
Yes, ma'am. Yes,
80 microfarad resistor. So this particular branch and this particular branch impedance is same. This is different. This is just twice of that, right?
yes, ma'am.
So now let's write the KCL equation. So if I write KCL, so it will be this V of C. So KCL at M V of C minus V of M by ZC plus V of A minus V of M by ZA plus V of B minus V of M by ZB will be equal to 0. So now I replace their values. So Vm, sorry, I'll take this. I'll take the circuit. So it is 200 phase voltage with an angle of 75 degree minus Vm. Let me just write in terms of ZC. We will replace Z like we can replace ZA by 2ZB or ZC, right? Plus the second branch, which is 200 minus of angle, sorry, for 165. This is VB minus VM by, in place of ZB we can also write ZC, since ZB and ZC are equal, plus the third branch, which is 200 angle 45 degree minus VM by ZA. In place of ZA, what can we write? 2ZC is equal to 0. Now we can take all the numerator and equate it to 0, so we can get rid of this unwanted Z terms. So it will be 200 minus 75 minus Vm. We have like taken LCM and taken the ZC to the right hand side and equated to 0, multiplied it with 0. So it will be 200 165 minus Vm, and in this case it will become divided by 2, right? So it will be 100 angle of 45 degree minus Vm by 2. This is fine. So we will take the Vm on the other side and simplify these angles. So Z angle of theta, this is written in phasor form, so we can write it as Z cos of theta plus Z jz of sin theta. We have done this in class in 2-3 previous classes, right? Do you remember? Can anyone confirm if you remember?
Yes,
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 ma'am.
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 Okay. Okay. So similarly we can do the same. So let's take 200 common. So not 200, let's take 100 common. So it is 2 angle of minus 75. We take common from this term and this term. So it will be 2 angle of 165 plus angle 45. This is 1 into angle 45. And we will take the Vm term on the other side. So it will be 1 plus 1 plus half. So Vm can be written as Vm into, so it will be 2, so 5 by 2. 100 into, so 2 into cos of minus 75 plus j 2 into sine of minus 75 plus 2 cos of 165 plus 2j sine of 165 plus 1 into cos of 45 degree plus j sine 45 degree. This will be the expansion. So we can write Vm equal to We take 5 by 2 on the other side, so it will be 2 by 5 into 100. Now cos of minus theta is cos theta, so 2 into cos of 75 will be equal to 0.517 plus j into, now sine of minus theta is minus sine theta, so 2 sine of 75 is 1.9318. 2 cos of 165 is, this becomes minus 1.9318 plus 2j sine of 165. It comes out to be 0.5176. Now cos 45 is 1 by root 2, which is 0.707 plus j, again sine 45 itself is 0.707. So if we simplify all this, so 20, so it becomes 40. So the j term and the non-j terms we can separate out. So we'll add up the j terms. 0.5 minus 1.9318 plus 0.707. So this comes out to be minus 0.707 plus j into, so this term and this term. So it is minus 1.9318 plus 0.5176 plus 0.707. So this again comes out to be minus 0.707. So this can be written as, so we can write Vm to be, if we just take the negative sign outside, so it is minus 40 0.707 plus j 0.707 minus 40. This is 1 by root 2, so j 1 by root 2, which is again for angle of 45 degree. So this is cos 45 degree and this is sine 45 degree. So we can write it as minus 40 angle of 45 degree, right? So what is the magnitude of Vm? This will be equal to 40, right?
Yes, ma'am.
Because so in the question it is asked, find the value of Vmn in volts. So Vmn is actually the voltage with respect to the neutral point, which is equal to 40. So we have got the value of Vmn. Now we have to calculate the value of Ia, Ib and Ic. So we can calculate this, right? We have the node voltage, which is here. We have the node voltage. So we can simply just calculate for each branch what is Ib, Ia and Ic. Can you calculate it now? Any response? So what will be equal to Ia? Let's take the circuit. So IA will be equal to
Vm minus Va upon Za.
right. So it will be 200 angle 45 degree minus, so minus of Vm by ZA. So 200 angle 45 degree minus, so Vm we have got to be minus 40 angle 45 degree, right? So it is, so minus of minus will become plus 40 into 45 degree, and ZA is, so we had calculated ZA, right? It is 80 by J79, whatever this value, 79.577. So if we just simplify these values, you'll be the numerator and denominator, you'll be able to get to IA. So how will you do this? Again expand, then, like, since addition cannot be done in this polar form, so you will have to expand in terms of I and j, and then add them up, then again convert it to polar form, and then divide the denominator. Is it fine? Are you getting it?
Yes,
Yes,
ma'am.
ma'am.
So this is just a simple plain calculation, like it's little bit time consuming, but right now for IA, since both the angles are 45 degree, so it won't be much of a problem. So it will be 240 angle of 45 degree, right? And you have to convert this in terms of the polar form, right? So the magnitude will be square root of 80 plus 79.577, right? This will be the magnitude in the denominator. So it is square root of 80 plus 79.577 square. So it comes out to be around 112.83. So it is 112.83 with an angle tan inverse of, so theta will be tan inverse of minus 79.577 by 80, right? So this comes out to be minus 44.84. So like ZA can be written as 112.83 with an angle of minus 44.84. So we can also calculate ZB and ZC similarly. It will be ZA by 2. So 112.83 divided by 2. So this will be 56.415. Right? This you are getting. So ZA, ZB and ZC you can calculate accordingly. So now IA will be equal to 240 by 112. So 240 divided by 112.83. So this is 2.1269. Since in the question the angle is not asked, only the RMS value of IA, IB and IC is asked. So the RMS value of IA is equal to 21.269 ampere. This will be the answer of IA. Now similarly IB also you can calculate. So let's take this. So IB will be equal to 200 angle 165 minus VM. So this will be minus 40 into 40 with angle of 45 degree, and this is ZB. ZB you can write, since we had calculated earlier, in place of ZB you can write 56.415, so it will be 56.415 angle minus 44.84. So in this case, since the two angles are different, we'll have to simplify properly. So let's take 40 common. So it is 5 angle of 165 plus angle 45 degree. Now we will expand this in terms of cos and sine. Let's take the numerator first. So we can write it as 40 into 5 cos of 165 plus 5j sine of 165 plus cos of 45 plus j sine of 45. So 40 into, let's write this. So this comes out to be minus 4.829, since cos is negative in the second quadrant, plus 5j. So I'll just multiply 5 into sine of 165. This comes out to be 1.294. Again, cos 45 is 0.707 plus j sine 45 is 0.707. So let us simplify this now. So this will be plus 0.707. So this is 2.001 and minus 4.829 plus 0.707. This comes out to be minus 4.122. So this can be written as magnitude of Z into angle, magnitude of like voltage, in this case it is voltage, into some angle theta. So this can be written as 40 square root of 4.122 square plus 2.001 square into tan inverse of 2.001 by minus 4.122. So let's forget the angle now, since we only need the magnitude. So the magnitude will be square root of 4.122 square plus 2.001 square, which is 4.582. So it is 40 into 4.582. So it is 183.28. So the RMS value, IRMS value of the branch B current is 183.28 by 56.415. This comes out to be 3.249 ampere. So this is the RMS value of IB. Similarly, you can calculate IC. It is exactly the same. Only thing is you have to like simplify the numerator. The denominator will be same because ZB is equal to ZC. Please calculate ZC and let me know if you get the answer. So what will be equal to IC? 200 angle minus 75 plus 40 angle 45 by 56.415 angle of minus 44.84. Can you quickly calculate IC? So you guys are doing it, right? Do you want me to calculate IC or you can do it on your own?
IC is equals to
Ma'am, tell me the final value, ma'am. We
3.249.
will solve it.
Okay. So the final value of IC RMS, let me hold on. Yeah. So IC will be around 3.25. So the IC RMS value. So it is the same thing. Like you will take 40 common, then expand this minus 75 into. So it will be, if we take 40 common, it will be 5 cos of minus 75 plus 5j sine of minus 75 plus cos of 45 degree plus j sine of 45 degree by this z value 56.415 whatever. So this is, you will put the value of cos and sine, simplify, convert it to polar form by taking square root of the whatever a plus bj, whatever a and b, you will take the square root and you can get to this particular answer. You will do it on your own, right?
Yes, ma'am.
Okay. Anyone has any doubt? Otherwise, we'll move to one last small problem and then we'll wrap it up for today. Anyone
Please
has any?
proceed, madam. Please proceed. No issue.
Sorry?
No doubt, madam. Please proceed.
Okay. So for the last question, it is just since in any of the circuit solving, like in Thevenin's and Norton's, you will have to end up finding the equivalent resistance. So this is just a practice problem to familiarize with the star delta conversion. So in this particular circuit, you will have to find the equivalent resistance RAB across the terminal, which is connected as shown. So in this case, it is not just a simple parallel and series combination. As you can see, like for example, these three node, if you consider, it is kind of forming as a delta circuit. Again, this type of these three node, like this one, and this one is again kind of forming in kind of a delta circuit. So in order to simplify this, you will have to use the star delta conversion. So let us proceed for solving. So first we will, whenever we see this kind of a circuit, if it is a delta kind of a connected circuit, we'll convert it to star. That will simplify the circuit. We'll see it as we proceed. So for the very first step, what we will do is, since we have to calculate the voltage across these two particular branches, so what we see is this particular resistance and this particular resistance, they are connected in series, right? Because nothing is connected in this particular node. It is just this entire this entire branch is a single branch in which two resistance are connected in series, right? So first let us simplify those part of the circuit which can be simplified easily. So this is R, this is, we'll keep the circuit, rest of the circuit as it is. So yeah, so this is the rest of the circuit which is as it is. Only the resistance that was connected here and here, we are converting it to an equivalent resistance, which is 2R, since they are both connected in series. Now if you consider this A and let's give this C and D. So across this C and D, this particular resistance and this particular resistance are connected in parallel. So we can again simplify the circuit, right? So let's keep the rest of the circuit as it is. Okay, this is this C terminal and this is this D terminal. So across this, what we see is these two resistors are connected in parallel. So parallel of R with 2R, so it is 2 by 3 times of R. So R into 2R by R plus 2R. So it is 2 by 3 of R, right? So now uh, if we look into this circuit, so we cannot straightforward say that these two may be connected in series or parallel, because these nodes are interconnected in such a way that it cannot simply be further you know uh, resolved into series or parallel resistances. So now what we have to do is do some star delta transformation. So in this case, if you consider this node E, F and D, this is kind of a delta connected circuit. So we have to convert it into equivalent star. So the equivalent star network will have a resistance in this form. Okay. Sir had shown the star delta conformation, star delta conversion. Uh, he has shown how to convert it, right? So imagine if you have a delta circuit in which there is RA, RB, and RC. So equivalent star network, which will be connected like this. So let us write this to be R1, R2, and R3, right? Or let's write this one R1, R2, and R3. What will be the value of R1? R1 will be equal to RA into RB by summation of all the resistance in the delta circuit, that is RA plus RB plus RC. The easiest way to remember is I'll take a different color. Wait. If a delta circuit is given like this, the equivalent star resistance that we will calculate will be a multiplication of the two adjacent branches RA and RB divided by summation of all the branch resistances. Okay. Similarly, can anyone say what will be equal to R2? R2 is from here to here. So it will be, can anyone tell?
RA into RC upon
Yes,
RA plus RB plus RC.
right. Summation of all the R. So similarly, like for this particular circuit, we will draw its equivalent star resistance. So let's redraw the circuit. So we had the circuit like this. So this delta, we are converting it to star. I'm just writing it in dotted line so that the whole line will represent the now whatever the circuit is. So now we are converting this portion of the circuit where E, F and D. This is the node E, this is the node F, and this is the node D. Right? Now again, the node here it is B B, F and C, this particular is a node. Please notice the node B, F and node C. This is another delta which we can convert it to star. So I'll just draw the node. So there is another delta circuit like this which consists of node, this is B, B, F and the node C. So between C and D the resistance 2 by 3 R is connected, right? So this is 2 by 3 R. However, whatever these two delta circuits are, we are just converting it to their equivalent star network. So the star network will be somewhat like this, right? Now let us calculate what will be the value of this R dash. R dash will be equal to the two adjacent resistance R into R plus summation of all the resistance R plus R plus R, that is R by 3. So each of the resistance, since all are equal to R, so each of this star network will now have a resistance of R by 3, R by 3, or R by 3. So now you will see this circuit has become much more simplified than it was before. So I'll redraw it properly. So there is a resistance R by 3. This is let this be the node uh, X and this be the node Y. Okay. So R by 3 is connected between, this is this node E and this is node X, right? Then between X and F there is a resistance R by 3 connected. Now between the node X and D R by 3 is connected. Now let's draw the rest of the node. So between this node is B, between B and Y, so there is R by 3 connected. So this is Y. Between Y and F R by 3 is connected. Between Y and C R by 3 is connected, and between C and D 2 by 3 is connected. So now you see that this X, F and this is Y, this is a single branch, so they are in series, this R by 3 and this R by 3 are in series. So we can simply write this as R by 3, this to be 2 R by 3. This is the point Y. So between B and Y there is one resistance R by 3. Now X, D and C is a single branch in which three resistance are connected in series. So from I'll just use a different color. So this entire branch is one single branch from X to Y in which two resistance, these three resistance are connected in series. So it will be R by 3 plus 2R by 3 plus R by 3. So this will be equal to 4R by 3. Now this branch and this branch are in parallel. So the equivalent resistance will be R by 3. Now these two parallel branches and the remaining. So let this be X point. So this is X point. So the remaining R by 3. This is B and A. Now this equivalent resistance will be 2R parallel with 4R by 3. 2R by 3 parallel with 4R by 3. So it will be 2R into 4R by 9 plus 2R plus 4R by 3. So it will be equal to 4 2s are 8, 8R by 9 into 6R into 3. So this will be equal to 4R by 9. So the net resistance RAB will be equal to R by 3 plus 4 by 9R plus R by 3. So 6R plus 4R by 9, 10 by 9R. So now whatever the value of resistance is given, which is given as 30 ohm, so it is 10 by 9 into 30. So it will be 33.33 ohm. So is this clear?
Yes, ma'am. Yes, ma'am.
So whenever like this a combination of resistance are given which appear to be in terms, like for this case it is appearing to be in terms of a delta connection, you have to convert it to its equivalent star in order to simplify it. Similarly, if it is given in terms of a series like star kind of a resistance, suppose the circuit had kind of star kind of a resistance, then if you had taken it in terms of its equivalent delta, the net circuit branches would be more simplified. This is how you can calculate the equivalent resistance. So yeah, any question related to the few problems that we solved today? If not, then we can wrap it up for today.
Madam, excuse me.
Yes.
Can we discuss about some issues of assignment 6, madam?
Sorry.
Some issues in answer key of assignment 6, madam.
Okay.
So answer of question number 3, A2.
Uh, so for whatever we had solved today, for that.
No, madam, assignment 6, previous assignment.
Okay, assignment 6. Okay.
Answer key, I think it is not correct for question number 3. So can
Okay.
you take up this issue, madam?
Okay, okay. Yeah, sure. I'll look into that. Hold on 1 second. I'll just write it down. Assignment 6,
Yes, ma'am. Question
question number
number 3.
3.
3.
All the values?
Madam, only A2 value correct answer is mentioned as 0, which is not possible, ma'am.
Okay. So this A2 value is given as wrong, you are saying?
Yes, madam.
Okay, okay. I'll look into it.
Okay, madam. Thank you.
Yeah.
Question number 3, A2 value.
Yes, question number 3, A2.
Thank you, madam.
Okay. Anyone has anything else to ask? Okay, then I'll stop the recording.